Hi, it's Miss House. I want to review with you a problem from the review on finding the zeros and graphing a polynomial function. Okay, so I'll do a couple of these. I'm going to start by doing number 6. So number 6 says the function is f of x equals negative x squared times x minus 2 times x plus 5. So that means the zeros are going to be 4. Now how do I know that? Because that's a 2, and that's a 1, and that's a 1, so there's a total of 4. Okay? Now we set each one of these factors equal to 0. And this is going to give us our x-intercepts, our zeros. These are all real numbers. And since they're all real numbers, they'll all be x-intercepts. Now, this one, okay, this very first one, is really negative x times x equals 0. So that's negative x equals 0, x equals 0. And the other x equals 0. So this one has a multiplicity of 2. Now, when it has an even multiplicity, that means at 0, okay, these are the same, right? You can only put 0 on the number line one time, okay? It's going to touch and turn there. At negative 5, since it occurs only once, it's going to cross, and at 2, it's going to cross. All right, so we got to keep that in mind. Now, let's look at the leading coefficient right here and the degree. So we already said the degree is 4, n is 4, and a is negative 1. So when you have an even degree and a negative leading coefficient, the graph has to go down at the left 0 and down at the right 0. So far, that's all we know. Well, that, and it touches and turns here. Right? Now, remember, I can't touch this x-axis anywhere else. So before I can do the final graph, I need to get my y-intercept. Okay, so my y-intercept would be, what would I get if I put a 0 here and a 0 here and a 0 here? Well, that's going to be 0, so that is my y-intercept. Okay, and remember, it touches and turns there. So we're going to rise, we don't know how high, doesn't matter, but we're going to touch and turn there, and then we're going to end up going back down here. Okay, we don't know the height of these peaks, because that is a calculus topic. But we do know that it has to go to negative 5, it has to go to 2, and it has to go to 0. And that it crosses here, and it touches and turns here, and that the ends go down. So that's how we graph that rational function. Okay, that was number 6. All right, now the next one I want to do for you is one that will require synthetic division. So I want to do number 18. Okay, and actually for 18 we can use factoring or synthetic division. x cubed minus 5x squared minus 4x plus 20 equals 0. Okay, now I look at this and I can tell that it factors. Okay, you might want to do it with synthetic division. So remember how you do that. Factors of 20 over, in this case, the factors of 1. Because there's a 1 coefficient here. So really we're just looking at the factors of 20. So plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 20. Okay? And you'll need to do synthetic division with these until you find 3 zeros. And of course, once you reduce this down to a x squared, you can then use factoring then or quadratic formula. Okay? To save some time, I'm going to start with one that I know is a solution. So I'm going to divide synthetically by 5. Now remember, you must count your exponents to make sure 3, 2, 1, none. Make sure they go down. So 5 is going to divide into 1, negative 5, negative 4, and 20. You drop the first number, 1, and then you multiply. 5 times 1 is 5. Add, we get 0. 5 times 0 is 0. Add, we get negative 4. 5 times negative 4 is negative 20. Add, we get 0. That means x equals 5 is a 0, and that means it's also an x-intercept, because if the point's going to be 5, when you put in 5, you get a 0. All right, now remember, we started with a cube. We've now reduced this down to a square. So this would be an x squared minus 4 equals 0. So look, x squared minus 4 equals 0. And this is fairly easy to factor. X plus 2 and x minus 2. You should definitely learn that difference of squares pattern. Okay, that gives me x equals negative 2 if I set the first one to 0, and x equals 2 if I set the second one to 0. So look, that's a 0, that's a 0, and this 5 is a 0. And that's 3 zeros, so that's all of them. Now, on this particular problem, they do not require us to graph it, but I want us to graph it because you'll need to do that on the test. So we're going to graph the related function, which is, let's see, let me write my zeros up here. 5, negative 2, and 2. Right? So the related function is this function, okay, not the equation, but the function. So f of x equals x cubed minus 5x squared minus 4x plus 20. And remember how we graph these. We do in behavior and intercepts. Well, zeros and the y-intercept. And remember that the zeros are the x-intercept. So both of these are intercepts. So we draw our number line. We put the smallest one on the left, the largest one on the right, and then of course 2 is right there in the middle. And so that would put my y-axis right here. Okay. Now to find the y-intercept, I do f of 0. So that would be a 0, a 0, a 0. It would be a 20. So this has got a different scale here on the y, but that's okay. We know it goes through 20, and we just want a general shape. We're not trying to be perfect. It's an odd, okay, so odd degree, or or n, we call n the degree. So they're going to be opposite ends. Since this is a positive, it's going to be down on the left and up on the right. So I know I'm down here and I'm up here, and I got to connect all of these points, and I can't cross the x-axis again. So I'm going up to here, down to here, and up to here. And so my graph would look like that. And that's how you graph a polynomial function. So remember, find your zeros first. That could be factoring if you recognize it. It could be synthetic division, and if this is a square, you can use the quadratic formula. But most of them are going to start out higher, so you're going to either have to factor or synthetic division at least to begin. So find your zeros, those are your x-intercepts. Plug in 0 to find your y-intercept. Look at the end behavior. If it's even, they go in the same direction. Positive, they both go up. Negative, leading coefficient, they both go down. If it's odd, that is, if the degree is odd, then the ends go in opposite directions. If the leading coefficient is positive, it's going to be rising on the right. If the leading coefficient happens to be like a -1 or a -2 here, it's going to fall on the right and rise on the left. Okay, once you have your end behavior and your intercepts, okay, you just connect the dots, right? Draw your end behavior in and then connect the dots in between. Keeping in mind that if you have a multiple root, it might not cross, it might touch and turn, and that's if it is a root that occurs an even number of times, okay, like in the previous example.